Hi class, Mr. Stemple here with your Bridge Designer lesson for POE. This will be the first in a series of Bridge Designer lessons using a particular piece of software. So what we're going to talk about today, we're going to start with a review of tension and compression. We're going to talk about tension and compression specifically in bridges. I'm going to do a little bit of an overview of the Bridge Designer software, and then I'll give you the assignment. So let's start with tension and compression. You probably remember this from last time. Tension forces are forces that are pulling outward on something, and compression forces are forces that are pushing inward on something. And then we spoke just briefly about how those forces work together in a bridge. You're going to get a lot more information on that today. So let's start with tension. Opposing forces are tension is an opposing set of forces acting on a beam or another object that are pulling outward, like the two guys there in the tug of war. They're both producing a tension force on that rope that's in the middle of them. Once you get started in the Bridge Designer software, you'll notice that beams that are in tension are marked as blue, and the darker blue they are, the more they are in tension, the more they have that tension force acting on them. As opposed to tension is compression. And that's the opposing forces that are pushing a beam or another object inward. If it's like the rubber ball there, it's going to kind of squish it. If it's like the block there, it may in fact break it if the compression forces are strong enough. And once again, when you start using the Bridge Designer software, you'll notice that beams that are in compression are colored in red. They start out pink and then they get really red as they get closer and closer to breaking. So when we get into Bridge Designer, once again, you'll notice that the beams in tension are in blue, the beams in compression are in red, and the beams on a bridge can go through generally either compression or tension, but there are some that will go through both tension and compression based on where the load is. So often beams are designed for either compression or tension, but sometimes they have to be designed for both. All right, let's talk about this software. Bridge Designer software. It is free software. You go to bridgedesigner.org and just go ahead and download it. It will have to install on your machine. It doesn't take a lot of memory space on your machine. It's pretty easy to run. And if you're not sure how to do it, I have another YouTube video that's up in the same Canvas assignment that'll show you exactly how to do it. And there's the link right there, or you can follow the link on Canvas. Once you have it installed, you can use the sample bridges, or you can create your own bridge from scratch. And you'll notice that the Bridge Designer software gives you detailed information about the forces, the tension or the compression forces that are on each beam of that bridge. And you can change the size, the shape, and the material of each beam in that bridge. And then, of course, you can put a stress test on the bridge, which is they run a truck over it, and you can watch the animation. It's pretty cool. Once again, my YouTube video is there. It's also linked to Canvas. That's the video that shows you how to download the software and build your first bridge in it. All right, then your assignment, build and test your bridge. So you're going to start with a sample bridge. The one specifically that I want you to start with this time is the Pratt Deck Truss Bridge, 44 meters, and that's explained in the video. Run the simulation, and then you're going to change two of the beams. You're going to change them one at a time. Change beam number 6, which is the one in the middle right here. I think beam number 6 is on the top. I'll show you specifically how to change it in the video, and then run the stress test again. And then put that one back where it is, or where it was, and then change number 17, which is the one on the bottom in the middle. And then once you've done that, run the stress test to see what it's like. What you're going to see there is you're going to see beams put to the limit of both compression and tension. So in compression, the beams are going to buckle, and in tension, the beams are going to break apart. So you'll actually see that happen as the truck gets close to the bridge and gets on the bridge. You'll see that they buckle. So it's kind of cool to watch the simulation. So notice as you're running the simulation, the tension and the compression on each beam. You'll watch them change color based on how much tension or compression are on each beam. Once again, watch the YouTube video. That's the same link that I've been putting up through the whole presentation. It's also linked on Canvas. You can also find it on my YouTube channel. And then your assignment is to make a cheaper bridge. using this same basic design, using the same truss bridge that you were experimenting with. I want you to make this bridge cheaper. And the way you do that is by changing the materials. Each beam has a specific cost, and that's laid out right up here in the materials list, basically. So you can click on one beam, just like you did in the practice session. Click on one beam and change its size, or change whether or not it's hollow or solid. And either of those things has an effect on its price. So what I want you to try to do is try to mess around with it a little bit until you can make this bridge as cheaply as possible, and you'll see the price of that bridge right here. It's right here. It's listed right here. Starts out at I believe it was $509,000 or something like that. And see if you can make it cheaper, and then take a screenshot of your cheaper bridge and upload it to me. Now, obviously, we don't always just want to make things cheaper. We want to make things constructed well, and we want to make them durable as well. But this exercise is really just making it cheaper and making it so that the truck can drive across it, even though it's a cheaply made bridge. So that's it. That's your assignment. Good luck. If you have questions, join my conference calls. If you want to watch the video for how to set up Bridge Builder and all the rest of it, it's also linked into the Canvas assignment. Good luck.